Welcome to CS 101, Modeling in MATLAB, Lecture 25 on Polynomials. Today we're interested in learning how to plot things in MATLAB, which should look quite familiar to you if you've used matplotlib pyplot in Python before. We're also interested in evaluating polynomial arrays, which are a particular way of representing polynomial equations that MATLAB can consistently differentiate, integrate, and manipulate in many ways. We'll also use this to start studying optimization problems such as locating function zeros or polynomial roots. MATLAB has a very powerful set of plotting functions and features. It's really one of the main attractions of the platform. The syntax of most of these plotting functions is quite similar to matplotlib, so you shouldn't need to memorize too many new things here if you're familiar with that library already. Typically in MATLAB, you'll begin by preparing your data set. Then you'll open a new plot by using the figure command, which opens a new window in the background for your plots. You'll then build the plot piece by piece using commands such as plot or mshow, and add titles, labels, manipulate the limits, and otherwise. One useful feature is to open up your plot, go to Tools, and go to Edit Plot. This will allow you to select features of your plot, such as a particular line, and it'll open up a dialog box that lets you choose salient properties of that particular feature. So for instance here, once this is done initializing, we'll be able to change things like the marker, the line type, the color, and other factors. So we can change the color to anything we like. We see those change. We can add lines. Here's a dashed line. We can change our markers, in this case to X's. And we can manipulate this to get something that looks very good for what we are trying to do. Once we're done with that and we have this looking the way that we want, we can also generate code which allows us to save everything that's taken place in this as a script which, given new X and Y data, would recreate the same figure again. If you need to save this plot, the best thing to do is go to File, Save As. There will be several options available. The default option is a MATLAB figure or a .fig file. This is compatible with MATLAB in that you'll be able to edit it again in the future, but it's incompatible with many other things that you may want to display this in. For most purposes, we recommend using PDF, PNG, or SVG, with almost all of your applications being covered by saving it as a PNG file. Subplots are useful for displaying multiple plots in the same figure. The subplot command requires 3 arguments: the number of rows, in this case 2, the number of columns, and the number of the current subplot that plotting commands will affect. So here we've plotted a sine wave, a cosine, tangent, and you'll notice that the asymptotes get the strange treatment that you frequently see if you don't choose your points close enough together, and an exponential curve.